Hello and welcome to this clip looking at heating a solid to collect a gas with a percentage yield application of the process. The reaction we're going to use is the thermal decomposition of copper carbonate into copper oxide and carbon dioxide. The particular copper oxide is copper 2 oxide because of the oxidation state of copper. So carbon dioxide is normally tested for using lime water, and it's normally taught at school as the observation being turning milky. But if we think about the calcium hydroxide in aqueous solution, and it makes calcium carbonate as a solid, as the solid forms within a solution, an aqueous solution, we call that a precipitate. So technically at A level you should call it a white precipitate, not milky. So I'm going to take you through how to set it up. Using the equipment list on the right, you take your copper carbonate, put it into a test tube in a rack, and obviously you can see I've got a stock bottle of lime water as well. So you put some of that into the other test tube. And I'll show you how to set it up so you can test for the presence of carbon dioxide once the reaction is underway. Okay, so you can set it up like this if you wish and clamp everything nice and securely. Depending on the stability of the carbonate, you may need to heat it using a Bunsen burner on a roaring flame, or if the carbonate is less stable, it can be heated using a safety flame. The main thing to remember is that you've got to remove the tube from the lime water first before you remove the heat. This prevents something called suckback. So suckback is when the heat is switched off first, creating a partial vacuum inside the test tube because the air in the tube starts to cool and it contracts in volume. That causes suction to suck the liquid up into the hot test tube, cold liquid coming into contact with the hot test tube and cause the glass to shatter. So to avoid that, I'm going to show you what technique we use. With the bone fished to the carbonate tube, and the other end of the rubber tubing in the lime water, you take the carbonate tube using a test tube holder, you heat it gently in the small flame in the red area until you start to see that the carbonate starts to blacken. This indicates that it's changing into an oxide, in this case copper oxide, and carbon dioxide should be good enough, which can be seen by the positive test result with lime water. Lime water turns milky, which shows that carbon dioxide has been boiled, carbonate must have been successfully decomposed. It's very important to avoid suckback, so remove the tube very carefully before you remove the carbonate tube. Okay, so to make that easier, you may wish to look at the assembly that involves the lime water with the test tube and don't cork it so you can take the test tube away easily, for example. So suppose you want to work out the percentage yield of your production of copper oxide. You measure the mass of the powder at the start and finish using a top-down balance, and the difference in mass will be accounted for by any carbon dioxide that's lost. You work out how many moles of CuCl3 you started with, and then how many moles of carbon dioxide gas you made using the value from step 2. Now you can use the percentage yield expression in this way. So the moles of carbon dioxide made that you just worked out is the same as the actual moles of the copper oxide made. So that can go on the top of the expression. The number of moles of copper carbonate you started with is equal to the number of moles of carbon dioxide you expect to make. So that goes on the bottom. So divide one by the other and multiply by 100. So let's now use some data. A difference in mass of 0.11 grams gives us that many moles of copper carbonate. So that's your expected amount. So that can go on the bottom. Now because they're equimolar, work out how many moles of carbon dioxide gas you made using the value from step 2. So 0.11 grams over its molar mass for carbon dioxide gives you 2.5 times to the 10 to the minus 3. So that means the actual number of moles of copper oxide must also be 2.5 times 10 to the minus 3. So therefore you put that on top and you get 6.175% as your yield this time round. Hopefully this is useful as an application. Thanks for listening. Until next time, see you soon.